Hello and welcome to Math World. Today we'll talk about inverse operation. Inverse operation is a skill we're going to learn to solve for a variable. So a variable is always kind of like a missing number. We don't know what it is. In earlier easy classes, you could say something like 5 plus x equals 7. What would x be? Now that's pretty simple. We know that that would be 2. 5 plus 2. But there's actually a skill, inverse operation, we can use that will always get us the answer even if it gets more complicated. All that skill is doing the inverse or opposite of what you see. First, look at your variable. I see this x sitting right here. Then, do the opposite of whatever operation is happening to it. I see that x is being added by 5. The opposite of addition is subtraction. I'm going to write my subtraction right below it to show that I'm subtracting 5. Now when I do it to one side, I have to also do it to the other side of the equal sign. Imagine this equal sign is kind of like splitting our problem up. And whatever I do to one side, I have to do to the other to keep it equal. So 5 minus 5, that becomes nothing, 0. And my x just comes down. My equal sign comes down. And lastly, 7 minus 5 is 2. So we use the inverse operation to kind of get an easy one. Now what if it gets a little harder? Like 7x equals 56. So what times 7 equals 56? And you may know the answer to that, but let's use inverse operation again. The opposite of x times 7 would be divide by 7. Again, let's split the problem up, divide both sides by 7, and these 7's cancel each other out, leaving just the x equals 56 divided by 7, 8. Yep, there's the 8. Alright, those are the two skills, the opposite of addition or subtraction, the opposite of multiplication or division. Now let's put them together. What about 5x minus 13 equals 57. Alright, a little bit tougher. You could probably figure it out in your head, but let's go ahead and just use our inverse operation since it's much simpler. I'm going to find my variable and do the opposite of what's happening to it. Now your first instinct might be to divide by 5, do the opposite of multiplying by 5. But we have to really use reverse PEMDAS. Since we're using inverse operation, we have to go backwards of our order of operations. And normally your order of operations says to do the multiplication first. Well, since we're going backwards or inverse, we're actually going to do the opposite of the subtraction first. So what's the opposite of minus 13? Plus 13. Let's split our problem up and add 13 to both sides. And draw our line. 57 plus 13 is 70. We bring our equal sign down. Negative 13 plus 13, well that cancels out. And we're left with our 5x. We now have 5x equals 70. A little simpler already. Lastly, the second part, what's the opposite of multiplying by 5? Dividing by 5. Just like we did up before, divide both sides by 5. The 5's cancel out, leaving only an x equals 70 divided by 5, which is 14. X is 14. We can even check to make sure this works by taking our answer of x equals 14 and plugging it back into the original problem. Let's go ahead and do that real quick. 5, instead of x, I'll put times 14, and then minus 13, equals 57. Well, using our PEMDAS, we know we have to do 5 times 14, which is 70, and then 70 minus 13 is 57, and it should equal. 57 does indeed equal, which makes us happy. So inverse operation is doing the opposite of whatever operation is occurring to our variable. Well, that's it, and I'll see you in class. Now for a word from our sponsor, Paper Cut Games. This week's game, oh snap. This is a dexterity game where you have a board full of these little pegs, and the goal is to pull them out to get points without this bar coming down and snapping you. So it's kind of like Jenga a little bit. So each of these have point values, like blue is the highest, and I'm going to try to pull it out without letting this red bar move. I think I got it without it moving. Let's try another one. Oop, that was worth a little less. And if I pull one that makes it move, the red bar moved, and it means I did not get the piece. So there's a discard. You keep playing. Ooh, that was a good one. Until, ooh, that's not a good one. Somebody, ooh, that one really messed up. So they don't get that point. Until it gets to the bottom. And at the end, you count up all your points and see who was the best at pulling out the pieces. So you have to have a little bit of carefulness with it, like Jenga. Ooh, lost. Oh snap.